Hi there all, we're going to be starting video 2 of the Interdiction blades. Basic work with this, we're going to take a very close look at the lights, and I'm going to show you the basics on the electronics, the concepts behind it, and basically how to put the circuits together for the light boards. What this is, we're going to be working with a power supply. It's very important that you have all your numbers right. I'll get into the math later. A switch that I've already pre-soldered, just a simple on-off toggle that'll turn the lights off and on. Your simple LED batteries, and for these ones I got a red case to actually insert the batteries into, since the blades are going to be glowing red instead of blue. Just a simple little cap that basically looks like some type of toggle. Alright, those are going to be inserted into the pipe, which should hopefully give it a more rounded glow. The issue that I had before with my first Ethereal blades was that the lights that I got was actually at a 15-degree angle. These ones I think are a 45-degree. I got these off of superbrightled.com. I'll put the link down below in the description. And we'll get into the basic concepts. What you're going to need in any type of electronics is the hot wire, which is red, is going to be your positive, blacks are negative. To create a full circuit, positive needs to go one way, negative needs to go to another. First step, if any of these lines cross at any given time, the strip will not succeed or glow. Lights have these too. You can easily test them. I'm going to turn the circuit to the on position. See, this is a closed circuit. Rather an open circuit, I believe is the terminology. The light power switch is on, but because this is on the negative with the positive side, and the positive is on the negative, you have an intermixing of flow of charges, and the circuit will not complete. And when I flip the light the other way, we get the glow just fine. With this, it's not too bright of a light because it's a smaller bulb, but once it actually is in the carriage, I think it'll be alright. Now, the trick, what we're going to be doing, is hooking up 2 more wires to basically extend it so that I'm going to have this farther away from the switch. Okay, basic equipment and cost. Battery packs, I believe, I got these on for 49 cents a piece. Shipping was a little bit extra because I had to expedite it. AA batteries. Switchboard, I got these at Radio Shack, I want to say for $1.50 for the 2. Lights, $1 each. These caps were 49 cents. Electronical wires are a little bit more expensive, I want to say, depending on where you get them. You can get them at places at Lowe's and Home Depot. Soldering iron itself was 25. So right now, just as far as basic supplies are considered, wires, you have your water-soluble Plex Flux, which actually coats onto the wires. It just helps the solder stick without causing burning. All the basic equipment costs about $35. If you want to get into the actual circuits and components, they're about $7 depending on what you're building. So it's something you definitely want to invest into if you're going to be dumping a lot of money into this, or you can get parts at a time. It's really not that bad. Definitely things you need, though, are your base wires. If you get them in different colors, you get your red and blues, or excuse me, red and blacks. That'll just help you differentiate what wires, what flow of energy is going which way, so you don't cross them at any time. And then other things to keep in mind. Oh, each battery, I'll grab another one that's out of the case, has a voltage power. I don't know if you can see that on camera focus. It's AAA 1.5 volts. Now each of these battery packs will have a 2 in them, so you're going to be adding to up to 3 volts of power. Each of these lights has a maximum of 3.8. So if you're able to hook these up to another battery cell, like maybe a 9-volt D, you'll actually burn out the bulb. So what you want to make sure is that your light capacity is going to be able to carry the amount of power at a maximum range so you don't burn out your equipment. So you got 3 volts going this way up into a 3.8 bulb light that should be able to carry the power just fine. All I know is for distant times, I've had my battery cells and my Taukaka lights for at least a good year, and as long as they're shut off to the off position, the battery cells do not run out themselves. Alright, so we're going to be going into this. And there you go. It's that simple. You definitely just want to be careful working with the soldering iron, just because I'm not sure exactly what temperatures the welder gets up to, but it's hot enough to melt metal, so you definitely do not want to burn yourself with that. I hope you can see that in a decent range of focus without me just moving up. Well, you can see that alright. It's all you need is just basically enough to make sure that the wires are going to be secured down in place. And a little goes a long way. Another thing that you want to make sure, since this is going to be an open and closed circuit just for the switch, is you want to make sure the solder that you put onto each of the wires stays within that toggle. I don't know, prongs, I think you want to call them. And again, black wires on one side, red on another. And so when this is in the off position, these 2 prongs are going to be not going to a complete circuit. So when this is on to the on, there's another strip that connects, there's another plate on the back end of this toggle that'll connect these 2 prongs and complete the circuit. So you have positive flowing on one side that will go up to the light, negative on the other. It's really that simple. This is my second welding job, and I think in the last maybe 8 years? No, longer than that. I took a basic home tech course back in, I want to say 7th grade, whenever that was. 23 now, so a very long time ago. But as long as you get the basic gist of it, it's relatively simple. Again, strip the wire back so that you're exposing the copper wire. Let's turn this on. Yeah, that's on. Just to be sure. And I'm going to be securing the right sides of the right. You don't need a lot to expose the copper wire. Just so that, another thing when working with the soldering iron, heat is a flow of energy. Copper is a conductor, so these wires will get hot if you leave the soldering iron on them for a very long time, so you just want to watch out what you're working with. And I think the long prong was the positive. Yep. Okay. I just want to bend this back so it ends up making a little bit of a... bend that back so it makes a little bit of a catch for the copper wire to sit on. Again, want to make sure the lines do not cross. Try to get these in with scissors. My big bulky wire cutters. Same thing with measure twice, cut once. Test thrice, solder once. Yep. I'm just gonna bend that back so it's all hooked up nice and neat. Another thing that you can do is get electrical tape to center off these, finish off these circuits. I'll do that when I get to that point. Also taking hot glue to the surface just encases it in a plastic. To my knowledge, the flux acts as, you don't need a little goes a long way with this stuff. The flux basically just acts as a surface for the soldering iron to adhere to. I'm not directly sure of its purpose. Somebody is probably going to watch this video and tell me all about it in the comments below. I'll look forward to those. Not the best thing to do, but I got my hands off the bulb. That's all it takes, really. And all I'm doing here is just solder. It almost acts like mercury when it's heated up. And it cools down relatively fast. It's a very cool metal. And that goes a long way. There you go. It's simple. Alright, we're doing the same thing to the other side. We have lights! Yay! I just like bending the wires, that way everything stays put when you're actually working and you don't... I know other people, more technical than I do, have probably vices and grips and things to keep these together. But since I am a poor alumni just getting straight out of college and everything else like that, I don't have a lot of cash on me, so one day I'll invest in the right equipment. No. Oh, I didn't use a flux. You don't have to. It's good to have, but if you don't mind your soldering jobs looking like a messy crap-tastic fun. Bleh. You're alright. I'm just in a hurry at this point because I think this video is getting rather long. Alright, there you go. Hold that up to the camera. You got a complete circuit. And this is off. And this is on. There we go. And you got the red light. And there's one to do. Awesome. Alright. Thank you so much. I'll see you later.